Our next presenter is very well known. He is the Executive Director of the Air Safety Foundation with AOPA, located in Frederick, Maryland. He's bringing to us today one of the great safety presentations that his section makes and takes all over the country. He's an instructor and an active pilot. He has over 6,000 hours. And he told me today that AOPA represents over 415,000 pilots. And there's only 600,000 in the system today. 2/3 of the pilots are AOPA members. His topic today is thunderstorms and ATC. Please welcome Mr. Bruce Landsberg.
Thank you, Walt. Well, good morning, everybody. I understand we had some thunderstorms here in the Lakeland area a while back, a few days ago. And if you had to deal with the aftermath, who flew in today or sometime during the show? Did you encounter any thunderstorms on the way? Nothing. Obviously, you didn't go west. Well, we're going to talk today about thunderstorms and particularly about how you and ATC interact with them. Before I forget, however, I do want to bring a couple of things to your attention. In the back, we have a couple of forms here which you can fill out and take to the AOPA tent for a drawing on a thumb drive, which will be very useful for you. You can download some of the programs that we have. And also there's a safety advisor in the back, which in case some of you aren't taking really good notes, I don't see a lot of clipboards out there, but if you're not taking really good notes, that'll help you to remember some of the things. George Orwell, back in 1984, which seems like a very long time ago, said to see what's in front of one's nose is a constant struggle. I kind of like the statement by one of the great philosophers of our time, Yogi Berra, who said, you can observe a lot just by looking. And this comes into our whole deal of flying with thunderstorms. We have some problems here in terms of accidents. Everybody probably knows somebody who has died in an aircraft. How many of you know somebody who's died in a thunderstorm? Probably. Does anybody know Scott Crossfield? You know him by reputation. We all know about that one, and I wrote about that this last issue in the magazine. But we want to talk about some of the problem areas and where people are having difficulty. About 80% of the accidents are us. It's not the hardware, it's not the system, it's us. We're going to need some sound here, guys. There should be some noise here, so let's make it happen up there in the control room. And let's talk about the number 4 pilot killer, and that's weather. And as you can see, natural forces impose the stress loads, which may exceed the aircraft's structural limitation. Sometimes it's us doing it, pulling the airplane apart. Sometimes it's Mother Nature doing it and causing the problem. Anybody have a problem with flying into that? Well, you should have a problem with it, but it's not too hard to see and avoid. We also have difficulty with VFR into IMC, and we have difficulty with icing. The lead cause of fatal accidents is VFR into IMC. And you would say, okay, that's a much more prevalent situation than thunderstorms. But we're still having too many accidents involving thunderstorms. I go back to the preceding picture. How hard is this to avoid? Well, sometimes it isn't quite as obvious as the cloud picture that I just showed. The thing is that almost all of them are fatal. And to put this in another word, this is a technical term that NTSB uses on accidents. You're probably toast. If you tangle with a thunderstorm, the outcome is not going to be good. So we need to take this positively. Okay, now that I have your attention, how many of you have taken our online course in thunderstorm avoidance? Okay, for those of you, this will be a little bit of a refresher, but we're going to go a little beyond that. And for the rest of you, you need to take this. Now, there is somebody out there that is counting the number of thunderstorms that occurs. I think they need to get a life, but it gives you an idea of the importance of how this deals. In this part of the country, in the southeast, we have a lot of thunderstorms, don't we? Why? Moisture, heat, instability. We should have a lot of thunderstorms in the Washington, D.C. area because of a prodigious quantity of hot air, but we'll not get into that. All of the problems that you see here with thunderstorms, turbulence is probably the largest one. And as in the case of Scott Crossfield, they can literally disassemble an airplane. And the lighter the wing loading on the aircraft, the greater the probability that we'll suffer an upset, which may then lead to structural failure. This is the cover page for the online course, as you can see, and the companion safety advisor, which we have lots of numbers here in the back. And we're going to go on a kind of a high-speed tour here of the course. And this is open to anybody. You don't have to be an AOPA member to take these online courses, but naturally we hope that you will. Anybody here ever actually flown inside of a thunderstorm? You have. Could you tell me a little bit about that? What did it feel like? It was an air mass thunderstorm, all right? Okay. Okay, so you ended up in a thunderstorm and your radar wasn't showing it.
And all I could say is on the other end of it, when I got out of it, thank you, God.
A King Air is a little bigger airplane than what a lot of us fly.
It was just, I mean, it was literally hairy because I was averaging altitudes of plus and minus 4,000 feet, and all I did was pull it back to the maneuvering speed, and just pray I could get through it. And I was watching lightning around me, and it scared the heck out of me, but the first thing I did was aviate.
Understand.
And when I got out the other side of it, I thanked ATC for turning me in that direction and said, don't turn anybody else. It gave me one thing. If ATC tells me to go somewhere and I see weather I don't like there, I tell them I'm not going there.
Hold that thought. We're going to talk about that in just a little bit. Part of the course here, we do a very quick refresher on thunderstorms themselves. This happens to be air mass thunderstorms. You can see them here, not particularly well organized, although over the state of Oklahoma and Arkansas it could be problematic. As we go into the frontal line thunderstorms, you can see that's a little better defined, and obviously squall lines are very well defined. Let's jump ahead here just a little bit. And this is kind of a recreation of what it might be like to fly inside of a thunderstorm. A Microsoft Flight Simulator doing the job in a Cessna 172. Notice the airspeed. I don't know if the airframe would actually creak like that, but we thought that might add a little bit to it. Now, some of you may remember Captain Bob Buck, who's the author of Weather Flying and grew up in the airline industry, started in DC-2s and went all the way through to 747s. And Captain Buck was a mentor of mine, and I'd like you to listen to his description of what happened to one of the TWA airplanes that flew through a thunderstorm.
We had a DC-3 go out of Kansas City down to Wichita, and the guy got in a severe hail in a thunderstorm, and he turned around to come back. The bank was such that it was on the high side of the airplane. It took out every window of the DC-3. Fortunately, it was a cargo airplane. There wasn't anybody in it. Took out every window on that side, and the elevators on the DC-3 were fabric covered, and it split, had various splits in the elevator from where he had up elevator, and the hail was hitting the elevator. And of course it just about flattened the leading edge and knocked out part of the windshield and landing lights and all that. We junked the airplane.
Obviously not something that we would want to engage in. And the DC-3, the bigger the airplane, the more controllable it's going to be, because as you get into the various swirls and eddies within a thunderstorm, if it's a small airplane and a big swirl, whatever you do with the controls is not going to work very well. There are some basic rules. I'm not going to spend a lot of time with this, but you can go around, fly under the anvil, which is probably not a good idea, and so forth. Let's jump ahead here just a little bit and talk about radar and the whole business of air traffic control services. How does radar work in terms of seeing thunderstorms? Anybody have an idea? Moisture, right. It reflects the moisture off of there. It cannot see clouds, and most radar, at least the kind that we have available to us, will not detect turbulence. We've got some radars on some very top-end airplanes that do have the ability to detect turbulence, but most of our radars don't. Again, we're jumping around here a little bit. Two different kinds of radar, though, that are employed by air traffic control, and the primary purpose of these is to separate airplanes. But we have added in the capability of being able to detect weather. All right? So there are two different kinds of radar. We have ASR, which is airport surveillance radar, and then we have the center radars, which are the long-range radars. There are some very important distinctions between those, and as an IFR pilot, you should know about this. So let's just jump ahead here a little bit. This is the display that the controller sees on the approach control radar. And what you have is what used to be called levels 1 through 6. That terminology is not being used anymore. All right? We have now more descriptive terms, which are light, moderate, and then heavy and extreme. As far as light airplanes are concerned, anything in the heavy to extreme level you want to avoid with as much distance as you can. Moderate, it sort of depends. If the weather is just developing and it's a fast developing type of weather system, you may want to avoid that as well. So this kind of describes what you've got there, and I can highlight here on the screen some of the different kinds of areas. Let's jump ahead here a little bit. The centers, obviously there are lots of different air traffic control centers out there, and they have a lot of different coverages. They get their radar feed not off of the antenna like the ASR does. ASR has its own weather capability. The centers get their radar feed from the National Weather Service NEXRAD, and they will get multiple feeds and sources that put all of this in. This is the display that we have on a center radar. Now don't ask me how we came up with the colors. Most of us are pretty familiar with the red, green, and yellow, and some of the controllers have said we sort of wonder about the shades of blue and so forth. But this is what we have. And you can see, now center does not describe light precipitation like the ASR radars do. All right? They do not describe the light precipitation. They start with moderate precipitation and work their way on up. So they will show 3 levels of weather. ASR, the approach control radar, shows 6 levels. So you can see that there's already a difference right there. So as I move the mouse over here, you can see that would be the extreme levels. This is the heavy level, and then there's moderate. Now this next slide is very important for you to understand the distinction, because we talk a lot about the distinction between tactical avoidance and strategic avoidance. Anybody give me an idea or distinction between those two? Describe the difference between tactical and strategic. Yes, sir, in the red.
Tactical is going to be where you have like an onboard radar and you could pick your way through, where strategic is where you're using, I have XM weather on my 182, and the strategic is where you're going to avoid the whole area and not try to pick your way through because of the age of the next rad and
exactly.
That type of thing.
That's the difference. So with ASR, you can get a little closer to the tactical environment. What we're going to do here is play. You see a block of weather up here on the screen. On the left side of the screen is what the ASR approach control radar will show. On the right side of the screen is exactly the same weather system as depicted by warp, weather and radar processor that the center has. So we'll go ahead and run this, and notice the clock at the bottom of the screen and how often the updates occur. You'll see ASR's already had 1 update, 2 updates, warp hasn't moved, 3 updates, warp hasn't moved. We're up to 4 minutes now. And finally, somewhere around 6 minutes, you'll get your first update with the center's radar, and you can see how the system has split apart just a little bit. That's an important point for you to remember. If you're talking to an approach control, you are getting near real-time updates. All right? If you're dealing with center, it's going to be delayed. Now, in some cases where they're getting a lot of feeds from various NexRads, the time might actually compress maybe down to around 4 minutes. If you're trying to pick your way through a rapidly developing system, 4 minutes is a long time. You can have cells develop from being a merely uncomfortable ride to a very dangerous ride in a light airplane in that period of time. Let us jump ahead here just a little bit. And this, again, will show the comparison between the same storm system. This is the ASR approach. This is the warp. And this is an older version of ASR. Jump back here to something that I wanted to show you. I'm still looking for it. All right, let's jump ahead. I'm now going to replay an accident scenario. This is actual ATC tapes of an accident that occurred up in the Midwest.
This is the tragic story of a real-life pilot-controller misunderstanding. What you will hear is actual ATC audio tapes of a pilot who was on an IFR flight plan being vectored around thunderstorms.
Can I bring the audio
He
up
will
just
pick
a little,
up
please?
Just as the first controller is handing him off to the second controller.
He's maintaining a blackout suit or something?
No, he's maintaining 10. It's quite bumpy out there right now.
All right, well, he's up to 10-8.
I didn't see him up there, so I'm up at 10-3.
He's been up to 10-8 twice, so just...
I'll let him know. All right.
Pilot was headed towards Milwaukee. Notice that the first controller makes it a point to tell the second controller that she's been providing vectors for thunderstorm avoidance. But also notice that the pilot does not confirm with the second controller that those vectors will continue.
So he's getting bounced around pretty good at 10-1. He's 12. I got him at a 270 heading to go around the south side of the weather that I'm showing now, southwestern Lansing.
All right.
Can I start him up?
Center call, straight back for 36, positive.
Please watch center lane there, experimental.
No, Roger, climb maintain 12,000.
12,000, thanks.
Roger, when you're able, proceed direct to Milwaukee on first.
Thanks, Milwaukee, thank you.
The controller's phrase, when able, is key to what happened next. The controller apparently assumed the pilot could avoid the weather himself, but the pilot assumed he was still receiving thunderstorm avoidance vectors.
Sparta, Lansing 30. Sparta, turning direct to Milwaukee now. He hasn't said anything about deviations, but he's your control for left or right deviations with me and Lansing. Okay.
Air traffic controllers may not know that a pilot's flight conditions could keep him from visually avoiding weather.
And watch him. He was having a hard time holding altitude at 10. He went up to 10-8 at one point, so might want to watch that experimental aircraft. Okay, I'll keep an eye on it. Thanks for the heads up, DC. I'm going to change his code, too, okay? Contact Chicago Center 128.5.
128.5. Thank you.
Moments later, the pilot transmitted, "Center, what do you show us in up here?" followed by a report of control problems. The accident was fatal.
Okay, so there are a lot of things going on here that perhaps don't meet the eye. What do you think? Let's just kind of take a quick poll around here. Anybody have any observations? Yes, sir. Oh, wait till the microphone gets down here.
My observation is that the pilot was not actively engaged in his own defense. He wasn't demanding information from ATC as much as he should have or could have under the circumstances. He was depending on ATC to provide for him, assuming ATC would provide, rather than requesting, asking.
Excellent point. As you see, as we get a little farther along, this is a two-way process in terms of communication. You have to let the controller know what you need and what your flight conditions are, and the controllers also have an obligation to provide you with some information. If a controller says, my system doesn't show weather, that's not true. That used to be true a long time ago. That's not true now. And if you can't get the information that you need, play it very conservatively. Don't argue with them on the air, but say, do you have, if it's a center controller, what does the warp show or something like that? That lets him know that you know what's going on. Their guidance is that they are supposed to tell you of weather that they see. Now, most of the controllers do a very good job, but occasionally you'll get one that's uneasy about the level of equipment. We have a lot of new controllers out there, and they're not comfortable with providing weather information. You should be asking about that. So we'll just kind of move along here, and you can see what's going on. ATC will make some assumptions sometimes, and that is that the pilot can detect the weather visually. Well, in fact, frequently we're in surrounding clouds and so on and so forth. We may not be able to see the thunderstorms that are embedded in a particular cloud deck. They may assume that you have onboard equipment to detect weather. In some cases we do, in some cases we don't, and so on and so forth. The other side of the coin is that the pilot is making some assumptions. So, for example, if I'm a VFR pilot, ATC is going to keep me out of the clouds. Does radar show clouds? No. The only thing that shows clouds that we have at this point is your eyes. So if you're VFR and you're on a vector for whatever reason, and it's going to put you into the clouds, you have to tell ATC, we'll be unable VFR on this heading or at this altitude. We have to change it. We make the assumption that they can see all the weather. The answer is that we don't, and particularly on a timing basis, there may be weather out there that is developing rapidly, particularly in the warp center side of the equation, that is not going to show up on the radar in a timely message. And we've got some quizzes here. Here are some examples of practice. This is a good one. I like this one here.
Delta 347, can you provide a ride report there at flight level 240? Delta 347, we've had light shot for the last 5 minutes. Delta 347, thank you.
Atlanta Center, Piper 12297, level 6,000 feet. What altitude was that Delta ride report from?
Piper 12297, radar contact, altimeter 294.95. Delta just flew over that line of moderate to heavy precipitation at flight level 240, 10 miles ahead of you. Your current flight path will take you through the precip.
This pilot did the right thing by monitoring the frequency and getting information from other pilots. He should also recognize that other aircraft might be overflying the precipitation. If this is the case, those pilots will do little to forecast what his ride will be like. Few GA airplanes can fly over precipitation and convective activity. Remember, you have 5 choices. Continue on your current flight path, fly over, deviate right or left, do a 180-degree turn, or land before reaching the precipitation.
That's a very good point. For us flying at low altitude, somebody that's in a high altitude airplane that's going over the same area of weather, and sometimes sectors, particularly less busy sectors, will have a pretty tall sector of airspace that they're working. The other airplane may be right over the top, and he's getting a great ride. This is one of the things that gets the controllers a little confused, because they'll be showing death and destruction on their scope, and they're having airliners go over the top saying, oh, we're getting a fine ride. Well, down below, that's what's going on, and we need to be verifying what altitude was that airplane. In this case, the controller picked up on it. In other cases, they might say, well, everybody else is going through, that's no problem. It may or may not be a problem for you, depending upon where it is. Let's pick another one here.
Cessna 751 Whiskey, try heading of 265. I just had another guy go through there and the ride was okay. Cessna 51 Whiskey, heading 265 for weather. Cessna 51 Whiskey, Miami Center, ride report when you get a chance. Cessna 51 Whiskey, we experienced continuous moderate turbulence. Cessna 51 Whiskey, okay, sorry about that. The radar just updated and it looks like that hole is closing.
This example highlights the drawback of warp. The information can be up to 6 minutes old. Many times, this may not matter, but as weather is building quickly, this delay becomes very important.
Need I say any more on that particular point, or do you think you get it? Timing is everything in a thunderstorm environment, and it goes back to an understanding of the nature of the weather system that you're providing. It would be nice if we could just say, the radar shows everything, no problem. As we get into the next section of the program, where we're going to talk a little bit about data link and how to interpret some of this, you have to take into context the general weather situation that you're flying in. So there's just an example of the online course, and those of you who haven't taken it, and if you do any IFR flying, or if you're a VFR pilot and would like to learn a little bit about what lays ahead, this would be a good thing to do. Captain Bob Buck, whom I already mentioned, I want to give you one more quote from him. And by the way, if you don't have this book, this would be an excellent book for you to get.
Now, as you approach a thunderstorm, let's say you're going in the leading edge, you look ahead and you see the cloud, and you see a roll cloud. And as you get up close to that, you'll suddenly get a tremendous rate of climb. You'll be going up like crazy, 8,000-9,000 feet a minute. And you're still out in the clear in many cases. Don't, for gosh sake, chase the airspeed. That's about the worst thing you do. Just maintain the attitude on the horizon. Don't go chasing the airspeed. If the airplane goes up, let it go up. There's no time to worry about ATC and all that sort of junk. Then as you continue, the vertical thing suddenly stops as you get in the rain area right ahead of you now. Now it has changed into chopped up turbulence. You're still getting a surges of lift that tend to make you want to pull the throttle back, but now you're in an area where it's raining crazy, really, really hard. You don't know whether you're in a submarine or an airplane. And it becomes very, very turbulent. Then all of a sudden everything stops and you fly out the other side of it.
If you understand how thunderstorms are built, you've got an updraft and a downdraft. That's a gross oversimplification, but that's generally it. When you get into the updraft, go ahead and ride it up. I've heard some rather amusing circumstances where a pilot will say, I'm unable to hold altitude, and the control will say, no problem, you're the only one in there, and you're on your way up. Recognize, too, that if you and another airplane that's 1,000 or 2,000 feet above you is in the same piece of airspace, they're going to be going up just as much as you are. The idea is to fly attitude, not altitude or airspeed. That's a very important point. The other thing is that if you find you're going to be flying into an area of cumulus that are developing, doesn't look like it's really bad, but you know it's going to be bumpy in there, slow the airplane down. Slow it down to maneuvering speed, just as you would if you were driving over a bumpy road. The airspeed is going to move around a little bit, and on occasions, and you've heard it here mentioned earlier, you can ask for a block altitude, and most of the time ATC will give it to you, and so on. So you say, well, can't maintain 8,000, could I have a block between 8 and 9? And then can I have 9 or 10? Whatever it happens to be. Here, as I make it very clear, you can't avoid, you easily can avoid storms like this. In this part of the world, though, frequently we'll have a lot of lower clouds, and it's a lot harder to see. So somebody who flies into one of the big Midwest isolated thunderstorms out there, you got to wonder what they were thinking. In my prior life, I worked at Cessna in Kansas, And I was an East Coast pilot and came out there, and I'd heard about the Midwest thunderstorms and everything. And I asked one of the senior pilots at Cessna, I said, is this going to be hard? And he said, not a bit. It's either flyable or it's not. There's no question about that. East Coast, we get a lot more of these marginal kinds of conditions, which makes it much tougher. Okay, so what are our options relative to this? Well, go around, okay. How far should we go around? 20 miles? Is that enough? Maybe. If you've got severe thunderstorms, the generally recommended guidance is 20 miles. Suppose there are a couple of them, because they usually don't happen just by themselves. How big does the gap have to be? 40 miles, if you're going to be sure about all of this. Can you cheat on that a little bit? Yeah, maybe, but you need to be very careful about what's going on. How far around is it going to be? Don't know. Sometimes the controller says, well, it runs off the end of my scope. Now you've got some other considerations to take into mind. Which direction do you want to go around? Well, we'll talk about that here in just a little bit. Can we climb above it? Not in the kind of airplanes that you and I are likely to fly. Even in jet aircraft, sometimes they're not going to get above it either. And this is frequently a good option. I had a situation years ago. I had my family on board. I was in a pressurized 210, and a strong cold front had moved through the East Coast, and I was flying down the coast towards South Carolina. And I had onboard radar and was kind of looking at everything, and there wasn't a whole lot of chatter on the frequency. And I asked the controller, I said, well, what do you see ahead? And he says, I got a lot of rain out there. And this is long before the days of warp or ASR. He said, I got a lot of rain out there. I said, okay. Have you had any ride reports? And he says, no, you'll be the first one through. That was the tip to me that maybe this wasn't the best thing to do. So I said, okay, I'm going to divert to, in this case it was Rocky Mount, and land. And he said, yeah, I think that's a pretty good choice. So we went into Rocky Mount and waited for about 3 hours. And the weather system moved very nicely off, and we went on about our business. And usually it doesn't take longer than that. So that's something to keep in mind, is land and wait. It's going to move through. Now, how far around can it be? It can be a long way around, and improper fuel management may lead to reduced undergarment service life. I want to talk a little bit about fuel management, and you might say, what's that got to do with thunderstorms and ATC? Well, it has a lot to do with it, because if you're adding some of those quality flying time to get around that, it's a pretty big deal.
Greetings from the flight deck, ladies and gentlemen. This is your captain speaking. Looks like our flight time to Hawaii will be about 5 hours and 20 minutes, give or take. We're trying to save a little gas by keeping the fuel load pretty light today. So just a heads up not to panic if you hear the engines shut down a little later in the flight, since we might have to glide that last little bit to Honolulu. Not to worry though, we almost always make it, so sit back, relax, and enjoy the ride.
This is what we call a pilot safety announcement. You've heard of public service announcement. Well, Air Safety Foundation has what we call pilot safety announcement. And you'll start to see this in a number of places. That number, by the way, is not too far off. 2 to 3 aircraft a week are crashing due to fuel mismanagement. Some of them due to thunderstorms getting around, and many of them just saying, well, I've made this flight 15 times before on this tank of gas. I don't understand why I can't do it today. So, not necessarily the best thing.
We all know that dependence on foreign oil is a problem, and a lot of us are doing something about it. We've cut our energy consumption and traded our gas guzzlers for hybrid cars. But isn't there more we could be doing? All across the country, pilots are joining the fight to end our addiction to foreign oil. They're carrying just enough fuel to get within gliding range of their destinations. Some are even conserving by walking those last few miles. After all, why waste fuel when your airplane can glide to the ground using gravity and the power of the wind? Hybrid power. It's not just for cars anymore.
I digress just a little bit, but I want to make the point. You people are not the problem. You're all here. Obviously, you've had enough fuel. We recommend what we call Air Safety Foundation's golden hour. You will be on the ground when you have 1 hour of fuel left in the tanks. Not thinking about landing at 1 hour. That you say, oh, I got 20 minutes to find an airport, an hour and 20 minutes from when the tanks go dry. That's where it should be. By the way, where are the fuel gauges accurate? 2 places. Full and empty. If you've had a gauge that's starting to trend towards empty, believe it. And you know, these things work pretty well, I've been told. Battery-powered, self-winding, the old mechanical way, either way, it's all going to work. Who's got data link? Pretty nice, isn't it? You can really see some stuff out there. Let's talk a little bit about data link and how we work with ATC in working with data link. Up here, you can see this is some pictures that I took flying AOPA's A36. And these are what I would call convective signatures. When you look at data link, we talk about the gradient, which is where the precipitation return goes from nothing to red in a short area. That is a convective signature. If it's got a very slow transition, it goes from nothing to green to yellow to red, and it takes a long time to do that. In the center part, it's heavy rain, but it's probably not convective. What you see here are convective signatures. Fairly widely scattered, probably not a problem to deal with, and over here you can see a picture of what one of those little cells looked like. It's this one here. Good VFR, can easily circumnavigate, and if ATC told me to fly through that, I would politely decline. Okay? Not that it's going to be dangerous, but it's going to be very uncomfortable because you're going to get some pretty good ups and down drafts, and that's just an isolated little cell. Now, the circumstance changes significantly here, where we now have widespread convective activity. Again, there are some ways that you might get through. You can see right over here. That might not be bad, but this is a very active weather situation here. And what looks good now may not be good later on. And if you look at the cloud pictures out there, that's looking significantly more ominous than what we saw before. By the way, this little hole right here in the middle is probably not a good place to go. There are various terms that will apply to that, but that's not a good place to be. Now, one thing that we talk a lot about is technologically advanced aircraft. Air Safety Foundation has done a study on that last year. And one thing we found is that particularly with the new technology aircraft, the Cirrus, formerly Columbia, now Cessna 350 and 400 series, and so on, we're seeing a disproportionate number of weather accidents relative to the numbers of airplanes in the fleet. Well, the counter to that is that these airplanes are flying a lot more cross-country than we think the comparable airplanes are. What you see here is one of the flight tracking programs, and these are Cirrus SR-22s and SR-20s that are up in the weather. Anybody figure out how many airplanes we got up there? Just do a quick count. I'll give you 10 seconds. The actual number is 13 aircraft. And some of these people are doing the right thing. These guys are going the right way, And you have to wonder what this guy is doing right here. But anyway, many more trips are being completed. So I can't give you a denominator or a rate of accidents per trip. So we don't really know if they're having more accidents relative to the rest of the fleet or not. But it's something to be aware of. If you have this kind of equipment, it needs to be used intelligently. And this happens to be a picture that I took of an airplane I was flying at the time, and we get the hopefully unfamiliar blue screen of death. Well, if you're depending upon your equipment to kind of work your way around through stuff, using it tactically, this is not a good situation to find yourself in. Here's another example. Who here has flown up the coast from Florida up to the Northeast? Do you find that there are a lot of thunderstorms right along the Georgia-Florida border as a regular kind of deal? It seems if I'm going to encounter weather, that's one of the most popular places. And sure enough, you can see the state line there outlined in black, and that's where we ran into some weather. The white line here is my proposed course line. Naturally, thunderstorms tend to form on the shortest distance between 2 points. I don't know how they do that, but they do. This is clearly a convective system, identified both by the gradient and the little lightning strikes that show up there. I also draw your attention to the time delay that we have here. This is showing that the next rad was updated at 1520, and we're at 1530 right now. So there's a 10-minute delay on this update. So that's worthy of note. This is that same storm system that you saw looking out the front window of the Bonanza. I'm at about 8,000 or 9,000 feet, just above a lot of the prevailing clouds up there, and you can see the storms off there. Which direction should I deviate? I'm headed basically northbound now. West? That would take me around this side here. East is going to take me around this side. If you look at the top of the cloud, you will see that it's blowing off. That we have a kind of an unusual flow here, and the storms are actually developing more to the west. So it would be better to go to the east side. This is now taken out the side window. That previous picture, by the way, was about 80 miles out. Okay? I'm now about 40 miles out. You can see the prevailing clouds are building up quite a bit, and I'm off the east end of this developing line. And if you notice down the line here, what was kind of a scattered or broken area is starting to develop as whatever it is moving in that direction. So had I deviated to the west, I would have had a much longer deviation to go around. And then finally, getting in pretty close here, again, that's the side window. That's how I like to look at these things, is through the side window, not the front window. You can see we're working our way around. I'm now up at 11,000 feet and not wanting to go too much higher because I don't have oxygen on board. And those cloud tops were reported above 35,000 feet. So not a good place to be. A relatively isolated little area, but if I'd gone around the west side, I probably would have had a 150-mile deviation. In my airplane, that's an hour. That's cutting into my fuel reserves now, and now I have to start thinking about what I'm going to do differently. One more data link scenario. This is coming out of Naples. This was last fall, and once again, you can see where my course line is. All right? Right through the middle of the storm system. Again, it's uncanny how that happens. So taking off out of Naples, and the controller, who has ASR radar, says, okay, I think a heading of about 320 would work for you. Well, 320 is going to take me right about here. All right? Now, the convective area is further to the east. You've got a couple of really big cells that are out there. I took a look at that, and it really looked all black and gray and terrible and miserable, and I knew what that was. And this is also, if you'll notice, my next rad update is right on. That's the latest and greatest. And remember, even with the update, that's when the signal was sent, not necessarily when the radar was looking at the weather, and you figure it takes them a little while to process it and so on and so forth, so it's probably a couple of minutes beyond that. Well, what to do? What do you think? Any other thoughts? I could go south, couldn't I? And just kind of work my way around the end here. We'll go to the other mouse. See, I could go completely around the end, and that would work. And here's an area here. There's a cell here, very clearly defined, and there's a small developing cell here. Well, perhaps I can go through here. There's an area of moderate rain. The controller said moderate to heavy. All right, now if I couldn't see that, I probably wouldn't have penetrated it. I took a look, and I said, you know, I think this will work, because I can see that the two cloud tops of where the cells are. There's a nice open area. This guy to the south is not very big. He is developing. I can probably work through this without too much problem. Not much rain in the middle there. Throttle the airplane back just in the anticipation that there might be some weather. I was also by myself. With passengers, I might have considered this a little differently. Flew through. The airplane didn't even get wet. I had one or two what I would call light turbulence bumps, and that was it. Flew out the east side and then proceeded on my way. So, same flight, same area. 10 minutes later, air traffic control is talking to Southwest Airlines and tries to send Southwest through that same area that he had originally tried to vector me. Captain said, let me think about that for a minute. Came back and said, you know, we'd like to take a 30-degree heading off. And the controller said, well, that'll take you a little farther out of your way. And the captain says, that's perfectly fine. I need the time in my logbook. So you are the final arbiter on these kinds of things. So when you get a vector, if you don't like what you see out the window, absolutely refuse it and say, no, that's not going to work. In some cases, particularly in high-density traffic, it's going to get tough, and the controller may say, I really need you to fly this. If you don't like what you see, you can say, sorry, that's unacceptable. And if the controller says, are you declaring an emergency? The answer is yes. And at that point, it's his problem or her problem to solve. I want you to look at how quickly this particular weather system develops. That's over the southeast. That was a period over a couple of hours. That's air mass. Okay? We talk about, everybody's concerned about fronts and squall lines and so forth. With the right kind of air mass, it can just absolutely explode. And in the course of just about 2 hours, you have the southeast getting to the point where it's going to be tough to find some open sky to fly at least comfortably, if not safely. So let's do a quick review here. Two types of systems, warp and ASR. If you have ASR, you're talking to approach control, you can probably take a little bigger bite of the apple because they're getting the updates more frequently and they're a little more granular in terms of what they're looking at. With center, it's going to be about 6 minutes on average. If the systems are not developing rapidly and so on, you can be a little more casual about it. If it's a strong system, be real careful about the updates that you get there. On the course, we have an example of an airplane that was talking to Miami Center who got vectored into a hole that wasn't there. They did survive, but the airplane was severely damaged in the process. ATC's #1 priority, separating traffic. Weather's important. Don't anybody tell you differently, but it's important. Workload permitting. Usually, when there's a lot of weather, there's a lot of deviations, they're going to be very, very busy. Don't assume that you're getting weather separation. One controller will be talking to you about weather. The next controller, when you hand off, what do you want to say to him? Let me know if you're painting anything out ahead. Keep me advised. And that should happen with each sector as you get down the line. Do not assume. If you see something out there, ask. What are you painting ahead? It looks to me like there's something going on up there. If you don't have any weather detection equipment, let them know. A lot of the controllers are used to the total airline environment. They've got lots of onboard radar. They've got dispatchers. They've got all kinds of equipment on board. We like to think, well, general aviation is ahead. A lot of us are not flying the latest and greatest equipment. So don't let ATC guess. Let them know that you do not have weather avoidance gear on board. Confirm the services. We've talked about that. This is an important one. If you see that there's a bad area ahead, don't drive right up to it within 15 miles and ask for a 45-degree turn. It's much easier for them if you let them know ahead, hey, it looks like we're going to have to deviate, would like to turn 15 degrees or 10 degrees off course. That's much easier than waiting to the last minute. We learned about this in the previous accident. When able doesn't mean now. When able does not mean now. Very important. Don't let anybody put you into a thunderstorm. This is also very important. Don't be afraid to say, can't do that. Unable is the key term. Okay, this is another course that we offer on sealing and visibility for the VFR pilots. Just a brief refresher on aeronautical decision making. And this applies to whether you're avoiding thunderstorms or whether you're deciding to land in a strong crosswind. Number one, anticipate that something is going to be problematic. That's just good decision-making, period. Secondly, when you've anticipated that something may go wrong, it's very important to recognize, whoops, whatever it is, the wind is stronger than I thought, the storm systems are building up, they're getting more widespread than I expected. Obviously, I'm not going to be able to get there. What's next? Do something about it. We have case after case. We're listening to pilots. They're talking to the controller and saying, well, you know, this doesn't look too good. Okay, so do something. Don't just sit there. You need to act. And then the final step is to reevaluate what you just did and see if that's working. Anticipate, recognize, act, and reevaluate. You don't have to get into any complex paradigms. Decision making is very simple, particularly as regards airplanes. This might also apply to your spouse's birthday. Just think that through for a minute and you'll figure it out. Here's one other sort of last-ditch effort, if you'll pardon the pun. If you get yourself into a situation and things are just going really badly, thunderstorm example, the clouds are all around you and you're not going to be able to get to an airport. The nearest function on your GPS isn't working, the batteries are dead, the storms are nowhere where you can get, or everywhere where you cannot get to where you need to go. Think about an off-airport landing. We did a study a number of years ago and figured out that in every single case where somebody had an off-airport landing, there was never a fatality. In most cases, minor injury or no injury. Yeah, the airplane got torn up a little bit, but no serious injuries. So we think about that. That's really important. A couple of thoughts. If you have aircraft insurance, AOPA has an accident forgiveness program, not Air Safety Foundation. Insurance companies do this. 3 insurance companies offer accident forgiveness if you participate in Air Safety Foundation programs. I'd like to close with this thought. We just mentioned that AOPA has 415,000 members, and we're very glad about that. Air Safety Foundation is a separate entity from AOPA. We're affiliated. We get 10% of our funding from AOPA. The other 90% comes from individual pilot donations. So as you're getting ready to make your donation to Uncle Sam this year, you might think about making a tax-deductible donation to the Air Safety Foundation. I can assure you that we will spend the money more wisely than your government will. That's not a high bar to get over. Go to the website, asf.org. It's free. You don't have to be an AOPA member. You can take any one of more than 20 online courses that we have. We do over 200 free safety seminars every year, no registration required, and so forth. If you like what you see, send us a check at the end of the year. If you don't like it, I'm the guy that needs the phone call or the email or the letter telling me about that. Last reminder, fill out your form here so you can stop by the AOPA yellow tent and get entered for the drawing for the flash drive. It's a good one, by the way. I think it's a 1 gigabyte flash drive, so that's worthwhile. And I will take any questions you have at this point. Sir.
Is the warp radar by center, is that, don't they usually control the airspace higher up, and the ASR radar is only for lower altitudes? Approach control, isn't it true that approach control usually covers airspace below 5,000 or 6,000 feet and center above?
That is correct. Typically, you will find center airspace. It depends on where you are. If you're in a fairly high density area, the TRACONs or ASR radar will go up to about 10,000 feet. That's typically the top of the ASR TRACON airspace. If you're in an area where there is no TRACON, then center will take it as low as they can see it. So it sort of depends. If you're in a high density area, again, like Florida here, you will not be talking to center very much. You'll be talking to the TRACONs, and for thunderstorm avoidance, that's a good thing, assuming that they're not too busy. Sir?
I have the XM data weather, which is the NEXRAD, and it's updated. You know, it doesn't seem to go much more than 6 or 7 minutes old. How does that compare to the updating that the ASR gets? Are they getting more real time, or are they similar to me getting the NEXRAD from NOAA?
The ASR updates are more frequent because they're actually looking at the weather. The ASR radar has the ability to look at weather. So it's what we call near real time. You're probably looking at every minute or so it's being updated. What the center is seeing and what you're seeing on your data link are very, very close in terms of timing. In fact, they may actually be identical depending upon who's doing the providing. So that's how that works. Sir?
Well, I've found in the aircraft that I fly, yes, I have radar in some of them, but others I have the storm scope and the NEXRAD weather, and I find incorporating the two of them keeps you out of most of the trouble.
Absolutely. Absolutely. Use all of the tools at your disposal. That includes your eyes, it includes all of the hardware, and so forth. And don't be afraid to ask. And if you get into a circumstance where things are just, starting to get snowballing and so forth, let's go ahead and land. We'll sort it out on the ground. I appreciate your time this morning. Thanks for coming out, and safe flights.
Feel free to shake his hand.
It's safe to come up. He doesn't bite.
Yeah, I don't bite.
It's always a pleasure listening to you.
Thank you very much. Appreciate you coming out.
Do you need something in Richmond? I'm there.
Okay, Mr. K, thank you.
A great landing zone, you can reuse the airplane.
Exactly.
Nice to meet you. I always enjoy your articles in there.
Thank you.
And a good landing.
Bruce, I want you to
Come on up, folks.
Come on up. Can you, in your programs online, put more pictures about different degrees of thunderstorms? It helps students understand.